All right, example 2.9, pre-calculus OpenStax. I like this example because it's really quite similar to examples we've done before, but it looks totally different. Right? This is very similar to this guy here, which was example 2.7. It's almost the same. It's just worded or given to you very differently. They give you everything algebraically here instead of graphically like they do up here. But you get the same information. What this statement right here is telling you is that when x equals 3, y equals negative 2. In other words, the point 3, negative 2 is on the graph of this linear function. And when x equals 8, y equals 1. So the point 8, 1 is on the graph of this linear function. And when you have 2 points, you have everything you need to figure out the linear function. So this asks us to find an equation for the function in slope-intercept form. So slope-intercept form is that mx plus b, where m is the slope and b is the y-intercept. So you come and look over here and you're like, well, I got 2 points. I can figure out the slope. Fine. Slope is, you can think about this a few ways. Say it's rise over run. So if you're an especially visual person, you could be like, well, when x equals 3, y equals negative 2. And when x equals 8, somewhere out here, y equals positive 1. And so I have this point and this point. And to travel from this point to this point, how much do I go up? Well, let's see. We'd have to go up by 3, it looks like. 2 to get back to 0, and then 1 additional 1 to get up to a height of 1. So if I'm thinking about slope as rise over run, the numerator in my fraction would be 3. And then how much is my run? How much do I go to the right to get from this point to this point? Well, if you kind of count over, even though it's a horrible picture that I drew here, I think you'll see that you go over by 5. So my slope is just 3/5. That's the m in f of x equals mx plus b. If you don't like thinking about this visually, if you're more of an algebraic person, you can say, all right, no problem. I got a formula for the slope. It's the difference in the two y coordinates over the difference in the two x coordinates. Note, this isn't like some totally different way of thinking about it. This is exactly what you did here. The difference in the y coordinates is how far you went up. It's this height, take away this height, gives you this distance right here. But at any rate, it's different steps that you do, so for some people it feels different. I'm going to arbitrarily name these points. I don't know, maybe I'll call this one x1 and y1, and therefore this has to be x2 and y2. If you thought this should be x1 and y1, totally fine, you'll get the same answer. So let's figure out the slope, just plug stuff in. y2 is the number 1 minus y1, which is negative 2. So in the numerator, I got 1 minus negative 2. Note that that's 3, just like I got over here. Kind of did that out of order. x2 minus x1, well, x2 is 8, and x1 is 3, and 8 minus 3 is 5. Same thing I got over here. 2 different ways you can think about what the slope is. I'm still not done because I need to know the y-intercept. If this problem were really nice, it would have said f of 0 equals something. It would have told me the height when the x-coordinate equals 0. That's exactly the y-intercept. That's what b would have been equal to. Unfortunately, it doesn't. It doesn't give me the y-intercept. I have to solve for the y-intercept. At least 2 options in terms of how you do that. One way is to use point-slope form. Point-slope form is the one that looks like this. If you have trouble remembering this formula, it's very similar to this guy if you take the denominator and multiply it over to the other side of the equation and drop the 2's in the subscript. At any rate, this is point-slope form. It's a useful form when you have a point and the slope, which we now do. Because I know the slope is 3/5. And I have a point. In fact, I have 2 points. I have more than I need. Let's use this one so that the subscripts match up, although you could use this point too if you decided you wanted to for some reason. Y minus y1 is y minus negative 2, aka y plus 2. X minus x1 is x minus 3. So what I now have here is an equation that represents this linear function. And if I can solve this equation for y, I have it written, I can then make it look like slope-intercept form. And so since it does specifically ask me to get this into slope-intercept form, I'm going to distribute this 3/5 through. A comment here, if it didn't say find the function in slope-intercept form, if it just said write the function, you could just subtract 2 from both sides. It wouldn't look like this. It's not the standard way you depict a linear function, but it works. It's equal. It's equivalent. But since it does say slope-intercept form, I'm going to go ahead and make it look like this. I'm going to take the 3/5 and distribute it through. So now I got 3/5 of x minus 9/5. And that's because this 3, you can think about it as 3 over 1. And when you multiply fractions, you multiply straight across. So this 3 times the 3 that's on top here, and this 5 times the imaginary 1 that's on the bottom here, that gives me 9/5. Then if I subtract 2 from both sides of the equation, I have to figure out what's negative 9/5 minus 2 more. I'm going to do this in 2 steps. And I want to subtract 2 here, but instead of saying minus 2, I'm going to say minus 10/5. I'm going to get a common denominator because I know that when I'm subtracting fractions, I need a common denominator. So now if I combine like terms, I got y equals 3/5 x minus 19/5. And really it said to write it as a function, so I guess I should say f of x equals that stuff. 3/5 x minus 19/5. I think I'm kind of beating this to death, showing you multiple ways to do this problem, but for anyone who's still sticking around, here's one last way you could finish up this problem. You don't have to use point-slope form. You can jump straight into slope-intercept form. You can say, I know eventually my answer is going to be f of x equals mx plus b, and I know m is equal to 3/5 from the work I did over here in green. So I could say, I don't know, maybe down here, f of x equals 3/5 x plus b. But wait, you don't know what b is. True, but I do know that when x equals 3, for example, y must be equal to -2. I know that f of 3 equals -2. So when I change all the x's into 3's, my f of x better be equal to -2. I got -2 equals 3/5 times 3 plus b. If I can solve this equation for b, I already got m, now I got b, I got everything I need for over here. Hopefully I'll get negative 19/5. If I don't, I'll pause this video and do it over again so you don't see that I screwed something up. So let's see, I'm multiplying through here. 3/5 times 3. Think about this 3 is 3 divided by 1. 3 times 3 is 9. 5 times 1 is 5. Get here. To get the b by itself, subtract 9/5 from both sides of the equation. This might be looking a little bit familiar. -2 minus 9/5 is -10/5 minus, I'll write it, sure. So I got that b is -19/5. If you choose to do it this way, don't leave this as your answer because this ain't the answer. The question didn't ask you what's the y-intercept. It asks you for the equation in slope-intercept form. So what I have to now do is use this and use this to copy this. And say f of x equals m x plus b. And instead of writing plus 19/5, I'm just going to write minus 19/5. And note that this is the exact same as this. Lots of different ways to do this example. I'll call this good here.